You need to know this before we get into it. What are large particle accelerators? CERN's Hadron Collider, LHC, is basically a massive 17-mile-wide ring of extremely strong magnets. It is the most destructive particle accelerator we've ever built. So strong it can almost recreate the earliest moments of the universe. It's a machine built to find the universe's secrets and could hold the key to even bigger discoveries. CERN, which started back in 1954, is a top research location with 23 nations involved. Numerous scientists participate. The place serves as a hub for minds to come together and invent things. The LHC is CERN's superstar project, but it's only one component of a substantial particle system. Think of accelerators and tests like a racetrack, but for tiny particles. The LHC makes protons go super fast, almost at the speed of light, then crashes them together. These collisions produce energy similar to what was around during the Big Bang. It gets crazy hot, much hotter than the sun's core. Magnets keep the protons on track, and special coolers keep things colder than space. There are 4 points where the beam hits the ring surrounding the particle detectors: Atlas, CMS, ALICE, and LHCb. Each one looks at different things in particle physics. They're like enormous cameras that take photographs of these collisions. Researchers examine the debris to find things like the super-rare Higgs boson, aka the God particle, and other particles that could show us how the universe is built. By looking closely at the tiniest stuff, we learn not only about the entire universe, but also uncover new questions. With each discovery comes a new test. The LHC isn't just a science tool, it's proof of people's curiosity and how far science has come. It shows that we really want to learn how the main forces shape the universe. But as we push the boundaries of knowledge, we also have to think about the ethics of it all. What could go wrong by looking into the unknown? We might accidentally unleash something we can't control. At CERN, where they're always testing the limits of what we know, something has come up that's even got the scientists worried. Brian Cox, who used to work at CERN and is well-versed in particle physics, said something that made everyone talk. He said that the LHC intends to produce a mini Big Bang, a miniature version of the beginning of everything. Cox also explained what this could imply, that the LHC could help us make huge discoveries, like finding out about the Higgs boson and dark matter, the mysterious elements that make up most of the universe. Imagine being able to fabricate the elements that form the universe. Sounds cool, right? But this is extremely risky. The mini Big Bang isn't just an idea. It involves actual heat, pressure, and energy, similar to what existed when the universe began. It's like being there at the very beginning. But with that much power, we must be responsible. What if something messes up? In fact, in 1978, something did go wrong. Anatoly Bugorsky, a physicist from Russia, had a really bad accident. He was working on a machine when a beam of protons hit him in the head, entered one side and exited the other. But he stayed conscious. He even walked to get help. He could still think, but the beam damaged some tissue. He lost hearing in one ear and had lasting facial issues. This demonstrates how potent and perilous these particle accelerators can be. We can't downplay the risks of a particle smasher like the LHC. There's always a chance of strange reactions, messing with the basic laws of everything. This isn't just science fiction. Real scientists have voiced concern. One of the scariest possibilities? That the LHC might make a mini black hole. Black holes have so much gravity that not even light can escape. They devour stars and bend space and time. The idea that the LHC could make one, even a tiny one, is shocking. Could it grow out of control and consume the Earth? CERN officials say any black hole would be unstable and disappear quickly. But the possibility, however small, still amazes and frightens people. To understand how a black hole could be created by the LHC, we need to grasp the basics. When protons crash together at nearly light speed, they produce such intense force that they can bend space and time. Imagine a trampoline. If you drop something heavy on it, it bends. If it's heavy enough, it could create a deep dent that pulls in everything around it. That's kind of what could happen at the quantum level inside the LHC. There's a belief that additional dimensions exist, ones we can't see. If they're real, the LHC might tap into them and create a tiny gravitational spot, a black hole. This caught the attention of scientists like Stephen Hawking. He warned that the Higgs boson could become unstable at extremely high energy levels, possibly causing vacuum decay, a phenomenon that could destroy not just Earth, but the entire universe. Sergei Martin Rees, a well-known cosmologist, also raised concerns. In his book about the future, he described a worst-case scenario where a failed test could cause vacuum instability, spreading across space-time and annihilating everything. He admitted it probably won't happen, but said we should still take the risks seriously. CERN researchers have tested theories and taken steps to ensure safety. Brian Cox said everyone worries about the LHC, but they have safety protocols. They check everything thoroughly. Cox reassured the public, saying Earth's natural energy levels are normal, and the chances of producing a stable black hole are extremely low. And even if one did appear, it would be so small and unstable that it would evaporate quickly via Hawking radiation. It would be a quick, cool moment, then gone. Some people believe the LHC could even open the door to another universe. Most scientists don't believe that, but it's become a popular fear. Could we accidentally unleash something we don't understand? The idea of opening a door to something bad has been blown out of proportion in the media, fueling more fear. But how did this all start? The concept of extra dimensions isn't new in physics. String theory suggests there could be more dimensions than we currently perceive, hidden ones that could be accessed under extreme conditions. Think of the LHC as a key to doors long closed. When protons crash with never-before-seen energy, they could create ripples that test these hidden dimensions. If those dimensions exist, the LHC could expose them. But it's important to note, while the LHC is powerful, there's no concrete proof it will open a door to another universe, let alone something dangerous. Still, the mystery of quantum physics keeps people uneasy. So, should we be concerned about the LHC and what it might do? It's easy to get caught up in fear-mongering and apocalyptic predictions. But the truth is this. The scientists at CERN are aware of the risks. They've implemented strict safety measures and carefully observe all their experiments. The benefits of this research, like better understanding the cosmos, discovering new particles, and exploring dark matter, are huge. This isn't just about showing off what humanity can do. It's about reaching into the heart of the universe. Like any big step in science, there are dangers, but we should be curious, careful, and respectful. The Large Hadron Collider is at the cutting edge of science. It's where the wildest ideas in physics meet real-life experiments. Its ability to answer questions, like where mass comes from or what dark matter is unmatched. Even with safety plans, the LHC evokes awe and concern. Its sheer size and the energy it produces are mind-blowing. Each new experiment leads to more discoveries. Yes, most scientists believe it's safe, but unknowns remain. What if something new and weird changes our entire view of physics? The LHC is pushing the boundaries of what we know, and how much control we really have over nature. These collisions recreate conditions unseen since the Big Bang. That's why these tests raise deep questions about whether we're tampering with the fundamental building blocks of the universe. Still, the LHC's contributions to particle physics are vital. It helped discover the Higgs boson, advance the Standard Model, and open doors to future breakthroughs that could change everything. Despite the risks, the desire to learn is deeply human. The path of science is never entirely safe, and the LHC is no exception. Its experiments peer into the very edge of physics, where much of our existing knowledge is incomplete. For years, physicists have struggled to unify the fundamental forces of nature, gravity, electromagnetism, the weak nuclear force, and the strong force. All of these contribute to how matter is formed. The LHC is proof of human intelligence and curiosity. It's taking us further than we ever imagined. It's not just a tool, it's a symbol of collaboration, bringing together brilliant minds from around the world to uncover the universe's greatest secrets. The LHC is trying to answer them. Questions that individuals have had for years. What are the fundamental forces that control our world? What are the true pieces that make up matter? How did the universe get to be where it is today? The LHC has already done remarkable things, like demonstrating the Higgs boson's existence in 2012, and it continues to push the boundaries of what we know. Every time protons crash inside the machine, there is the possibility of discovering something new, from brand new particles to phenomena never seen before. But with great power comes great responsibility. Scientists are aware of the risks, both known and unknown, that come with tests at the edge of physics. The concept of controlling forces that created the universe, or triggering events like mini black holes, causes concern. Physicists such as Stephen Hawking have issued dire warnings about what could happen, such as vacuum instability. While the chances of such catastrophic events are low, the mere thought of them captures both public fear and fascination. For some, the LHC is a symbol of humanity's desire to control nature, to exert influence over the forces that run the cosmos. For others, it is a tool to uncover the basic nature of reality. But trying to learn comes with consequences. As with all science, there are ethical problems and unforeseen risks. What happens when we gain the power to learn the darkest secrets of the universe? Should we stop and ask whether we're ready for the answers we might find? Beyond the known, scientific risks, and the LHC's exciting possibilities, its existence also raises profound philosophical questions. The scale and ambition of the LHC force us to rethink not just how we know things, but what we know. Scientific discovery has always pushed the boundaries of human understanding. However, the LHC operates at a level where observation becomes abstract, and data must be interpreted through highly intricate mathematical frameworks. This raises a unique challenge. When evidence is layered in quantum uncertainty, how do we distinguish what's real from what's theoretical? Additionally, the LHC highlights the increasingly collaborative nature of modern science. No single nation could build or fund a machine of this magnitude alone. It is a group achievement involving thousands of researchers, engineers, technicians, and students from all over the world. Working toward a common goal, the LHC embodies a rare and valuable spirit of international cooperation, especially in a time when political tensions often divide countries. In this way, the LHC is not just a scientific project, but a global symbol of unity in the pursuit of knowledge. Another point worth considering is how the LHC's discoveries may influence other scientific disciplines. For instance, breakthroughs in our understanding of subatomic particles can trickle down into advancements in chemistry, nanotechnology, material science, and even medicine. The foundational knowledge from these experiments could lead to better imaging techniques, faster computing, or novel energy sources. Historically, fundamental science has often paved the way for unexpected technological revolutions. When scientists first began studying quantum mechanics, they had no idea it would someday lead to microchips and smartphones. The massive volume of data generated by the LHC is another marvel in itself. Each second, detectors collect information from millions of particle collisions. To make sense of it all, CERN had to develop some of the world's most advanced systems for processing data. In fact, the requirement for high-volume, high-speed computing led to the development of the World Wide Web at CERN in the 1990s. Today, their global computing infrastructure is a kind of supercomputer that spans continents. This immense data analysis capability not only benefits physics, but also sets the stage for breakthroughs in artificial intelligence and machine learning. There's also an interesting cultural angle. The LHC addresses concepts like dark matter, antimatter, extra dimensions, and the very birth of the universe. As a result, it has captured the public imagination in a way few scientific projects have. It frequently appears in movies, books, TV shows, and online lore. This media exposure is a double-edged sword. On one hand, it gets people excited about science. On the other, it may propagate false information or fuel fear-based narratives. Still, the fact that people are talking about quarks and bosons over dinner conversations shows just how powerful the LHC's influence is beyond academic circles. Meanwhile, ethical considerations continue to evolve. Should there be a global framework for regulating high-energy physics experiments, similar to international treaties on nuclear weapons or genetic modification? Some argue that pushing the limits of reality at the quantum level should come with checks and balances. The concern isn't only about catastrophic failure, it's also about the responsible stewardship of knowledge. Once a discovery is made, like a new state of matter, or a method for altering the vacuum state of space, who decides how it's used? At the same time, it's important to recognize the LHC's contribution to education. It supports countless PhD programs, internships, and research fellowships. It goes beyond expanding our knowledge base. It trains future generations of scientists and engineers, many of whom take their skills into other industries, advancing innovation across the board. The LHC's influence spreads far beyond physics, into computing, communications, finance, and electronics. Through its complex modeling methods, the LHC exemplifies humility in the face of the unknown. Unlike some areas of science that work with clear hypotheses and expected outcomes, particle physics accepts that not every experiment will yield definitive answers. Many discoveries at the LHC have taken years to verify, and some are still being debated. This patient approach to uncertainty is a vital lesson in a world increasingly obsessed with quick results and instant gratification. Lastly, the LHC challenges our understanding of the universe, not just in scale, but in purpose. Why are we trying to decipher the universe? Is it because we can, or because we believe it holds meaning for us? Are we driven solely by curiosity, or is there an underlying hope that, through science, we can answer age-old philosophical questions regarding the meaning of life and even consciousness? Regardless of whether the LHC ultimately reveals the secrets of dark matter or extra dimensions, its real value may lie in what it represents: humanity's unending quest to explore, to ask, and to understand. It reminds us that the biggest leaps often begin with the smallest particles, and that even when we peer into the fabric of the universe, we're also looking into ourselves.